JAMB 2026 candidate, welcome to today's lecture. If you want the list of calculation topics that JAMB selected that they are going to set calculation questions from, you can send me a message on WhatsApp to get it. Or do you want a sharp plan for last minute preparation? Or you want simplified lesson notes that is very short, that is going to help you prepare very fast? Or you want to join my direct mentorship? Any help you need, I help JAMB UTME candidates to pass easily. You do less and you score more. Send me a message on WhatsApp. This is my WhatsApp number. All right. So now let's look at the question we have here. Under the topic, specific heat capacity as what suggested and recommended by JAMB. Okay, so if you look at the list of the topics where JAMB are going to set calculation questions from, if you look at that file, you are going to realize that specific heat capacity is number 9 or number 10. All right, so the question we have here, JAMB must repeat question 1. The question reads, a piece of substance of mass 2 kilogram and specific heat capacity 4,200 joule per kilogram per Kelvin is heated from 25 degrees Celsius to 35 degrees Celsius. Calculate the quantity of heat absorbed. Okay, he said we should do what? Quantity of what? Heat absorbed. All right, and the options, first of all, we look at our options. Options are represented in joule. Okay, joule. Look at the unit that the options are represented in. Can you manipulate it? No, we need the formula. We need to use the what? The principle to solve this and get the answer. All right, so what are we going to do immediately? We quickly write out what we were given. Okay, we were given what? What were we given? What were we given? What were we given? What were we given? The first thing that we're given here is the mass. The mass is what? Equal to 2 kilograms. All right. We were given what? Specific heat capacity of 42,000. 42,000. Specific heat capacity. What is our specific heat capacity? Capital letter C is equal to specific heat capacity 4,200 joule. Always write the unit per kilogram so that you know when you need conversion per what? Kelvin minus 1. So they also gave us theta 1. The temperature is represented with theta. You can also represent it with T1 temperature. Let's just write T1, okay, so that more no confuse you. But now theta they take the representer. Let's just use what they normally use to represent it, theta 1, okay, theta 1, okay. The first temperature from 25 degrees Celsius equal to 25 degrees Celsius towards theta 2 is equal to what? 35 degrees Celsius, okay. Okay, so we are looking for, they said we should look for what? The quantity of heat, okay. Quantity of heat, which is Q, is equal to question mark. This is what we are looking for. So what is the formula for quantity of heat? The formula for quantity of heat is Q is equal to what? Is equal to MC change in temperature or times change in temperature. Where our change in temperature is theta 2 minus theta 1. That's the change in temperature. So to get our change in temperature, let's get the change in temperature here. Okay? Change in temperature is equal to theta 2 minus theta 1. Okay? So change in temperature is equal to 35, which is our theta 2 minus theta 1 minus 25. So change in temperature will now finally give us what? 10. Okay, so our change in temperature is what? 10. So we are now going to bring in this formula and use it to solve. Where Q now, our quantity of heat is equal to M. What is M? M is mass. Okay, we have it here, mass. Mass, which is 2 kilogram times, what do we have? C, which is what? Our what? Specific heat capacity. 4,200. Okay, 4,200. Okay, times what? Change in temperature. We already have it here. That's 10 times 10. Okay, Q now, which is quantity of heat, is equal to 2 times this. 2 times 4,200 will give us 8,400. 8,400 times 10 will give us 8,400 times 10 will give us 84,000 joule. Among the options, pick the correct option and drop it in the comment section. Easy mark. Follow me for more easy mark. Subscribe to my channel for more easy mark. JAMB 2026 candidates. See you in the next class. Still on that specific heat capacity, let's take JAMB must repeat question 2. Question that they always repeat. JAMB always repeat it. All right. The question read: a copper calorimeter of mass 0.5 kilogram and specific heat capacity 400 joule per kilogram per Kelvin is heated through 20 degrees Celsius. Calculate the heat absorbed. Another heat absorbed again. First of all, let's write out the formula for calculating the heat or the quantity of heat. Okay, heat absorbed. We'll see the same thing, quantity of heat. All right. So Q, which is quantity of heat, is equal to what? MC change in temperature. This is the formula for what? The quantity of heat. Let's now write out what we were given. So we've already looked at the options. They are all represented in joule, and we can't manipulate it to get the answer. So let's write out what we were given. Okay, given the first thing where they give us here now, waiting, the mass of copper, which is 0.5, mass equal to 0.5 kilograms. Always write the unit. We were given what? Specific heat capacity, which is 400. Okay, specific heat capacity, which is equal to what? 400 joule per kilogram. Minus 1 per Kelvin, minus 1. All right, so it's heated through a temperature of this one. They only give us one temperature, which is 1 theta. That's what they give us, theta equal to 20 degrees Celsius. Okay, so they ask us to calculate the heat absorbed. Okay, quantity of heat equal to question mark. So we are looking for what? Quantity of heat. All right, so the formula for quantity of heat is equal to MC, specific heat capacity, times change in temperature. So if we substitute, we are now going to be left with Q, which is quantity of heat, is equal to what? M. What is M? Our mass is what? 0.5 times our specific heat capacity is 400 then times our what? Our what? Temperature. We don't get temperature change. Now only one temperature they give us. Okay, times 20. Okay, so if you times 20 times 400, or 400 times 20 will give us what? 400 times 20 will give us 4,000 times 0.5. Yeah, heat quantity. That quantity of heat now is equal to 0.5 times 4,000 will give us 2,000. Okay, 2,000 joule.